Anybody want to take a guess on the year? Okay. Not much different to what we do today. There is a slight difference. This is very pixelated, obviously. This would have taken possibly a week to produce because of the computing power we had. It was far less than I've got on my telephone at the moment. But things didn't stop. They advanced. And so we have much better models, 3D models, still in the plant area, because there was money in that activity that could pay for the use of these technologies and find out more leaner ways of working. So anyone want to guess on this one? Keep you waiting, but the computer will. Sorry, I'll go back on that. We're running into the early 40s. See, that doesn't go backwards. So this is into the 80s, so just before the crash. We were really beginning to build good models and getting good returns. We could tell that would output for us the go-tos. That is, where does the pipe come from, where does it go to, fully listed out, all tagged, all the information about it, and on the centre line of that information it would tell us what the performance requirements and the design inputs were to derive that model. It was design driven by and large. But the technology was showing great promise, but to be honest, that all disappeared, as I said, in the late 80s, early 90s. We started again. And that promise, that 3D modelling activity and the power of that is still to be realised. One of the things that we started to look at that time, I will go back a bit, 73, 76, was recognition of waste in our industry. There are a number of books produced from our building research establishment that showed that errors in building construction could account for possibly 10 to 20, 25% waste in our industry. And if you can get hold of a copy of this book, you will find all of the reasons for it. The major one was inaccurate and ambiguous information. What does that mean? Israel had a look again a little bit later on, a couple of years later, with exactly the same problem. 1982 was still there. We had done nothing about it. And in this one, it was the lack of spatial coordination in uncoordinated MET documents had cost overruns of 40%. In fact, part of the report was that 50% of the MEPs, the MDEs and Ps, time on site, 50%, was spent trying to figure out how to solve the problems that they had on the information that they were going to build from. We also know from the Construction Project Information Committee presenting at the RIBA, looking at the quality and the quality reduces waste, one of the principal qualities of good design is integrity. It is equally true that if the information used to communicate that design does not also possess that quality, then the design itself is placed in jeopardy. So it doesn't matter how good a design we've got, if we don't convey how it needs to be built and put together, it will fall apart by and large, or certainly will not live up to its expectation. The other thing that came out of this, which really goes back right the way to 1900, 1901, is information is invariably inaccurate, ambiguous, and incomplete. Do we have a problem today? Do you think? Well, let's see how many have seen this before. I won't speak around. I've had this on my presentation for about 20 years. What this represents is two drawings, one produced by the architect, one produced by the structural engineer, signed off, checked, reviewed, and signed off as fit for, suitable for construction. Goes on to the site, as we used to do, stick the drawings one on top of the other, push it onto the site window, wait for the sun to shine, and then we all knew that the planning for that day had gone to pot. And first of all, we had to figure out what we were actually going to build. So this is an interesting little exercise. First of all, why is the structural information in a different place to the architectural information? Dimensionally, And the answer is because I didn't trust the information, I needed to redraw it myself. Okay, I'll accept that. But why did the structural engineer draw the doors? Perhaps they were holding something up. I don't know. So we have this overproduction of information. Why are you doing all this work when it's not necessary? If you had actually spoken to the architect and said, why is your drawing dimension incorrect? Or perhaps it wasn't. Then I could have saved myself a lot of time and effort. If I could reuse the information that the architect had produced, even in 2D, I don't have to accept the risk of redrawing it because I attract risk by re-keying or rewriting their information. I attract risk by doing that. I could have solved a lot of these problems and done this work in half the time, and spatial coordination would have happened as part of the process. But no, we don't talk to one another. I don't trust what you've done. I'm going to redraw it, etc., etc. And they're all signed off, fit for construction. So how did the architect, sorry, how did the engineer sign off his drawing if he didn't check it in context with the architect's information? We don't talk to one another. And this goes on. We have problems of lack of change management. This was quite an interesting one. There happens to be Manchester Piccadilly Station, where there was a design where the staircases were going to go up at 2 angles. That's architectural design. And somebody decided, well, we need to speed that up a bit. We'll change the design. We'll have 2 straight staircases. We can manufacture those quickly and install them quickly. They failed, unfortunately, to tell the architect that's what they've done, and they failed to tell the site that that's what they've done. So this information arrives on site, just on a simple overlay, and we've got people saying, are we supposed to draw it? Are we supposed to model it? Are we supposed to build it? What are we supposed to do? Ambiguity. And in this simple exercise, first of all, the architect has asked the structural engineer, how much space do you want in this building? And they've agreed how much space is needed. The architect has indicated the stance of there, but when the structural engineer came to design it, finally, it's bigger. So not only is it bigger, he didn't tell the architect like that, he actually put it in a different place. Why? And so these 2 drawings end up on the site again, and once again we have ambiguity, telephone calls, RFIs. We start wasting time trying to sort out what the problem is. Obviously there's not much we can do. We have a structural steelwork member on the site, just about to be erected, and it's going to hit the wall. What are we going to do about that? Put the brick somewhere else, perhaps. As I said earlier that the M, the E's and the P's spend 50% of their time on site trying to solve the problems that have occurred in the data set. So everything painted red there is actually a site fit. Why? Because somebody only understood how to coordinate things in 2D, but they didn't take account of the vertical separation. In fact, in the piper's mind there was no problem. Because that trunk didn't exist, perhaps, in his mind. Why? Lack of collaboration, lack of information, lack of coordination. Money, money, money. So waste in the construction, cost and time overruns are normal, and nothing has changed since 1973-76, or with the advent of accurate CAD tools. We are still, and they were all CAD drawings there by the way, we're still producing drawings in the same old way with the same old processes that we always use for doing things on paper. And nothing has changed. So the technology, in fact, up to this point, has been negative in making us more efficient than positive. What we do get people doing is, have you seen my wonderful visualization? Look what I've got on the front of my magazine this week. How much value does it have in the delivery of production information? Technology is used for other things, more exciting things perhaps. But using the technology to overcome the problems and get rid of the waste is a problem in our industry. Will the BIM tools be used any better? Can the BIM tools, in fact, make a difference on their own? Whatever a BIM is. So it's just one of my little pet things here, that when I was a structural engineer and a draftsman, because we were designing detailers in those days, I wasn't actually called a pencil engineer, because I could operate a pencil. But for some reason now, you have to stick this BIM badge in front of everything. I'm a BIM manager, I'm a BIM operator, I'm a BIM engineer. And we go even further in this ability to show how good we are. We now have digital engineers. Not quite sure what one word is. I will be derogatory about this, and you can have any go you like at me later. The focus of the use of 3D object modelling has been primarily, up to now, for spatial coordination purposes and for clash detection. So we now have brought into all of this, we have 3D modelling, and we've brought in a whole new process, checking management process, which is called clash detection. Why? Well, I know I make mistakes, you've seen them all on the drawing, so what we do is we hire a third party and we give them all of our models and get them to work over the weekend and tell us on Monday morning what we've done wrong. What a waste of time. What a waste of money. What a waste of effort. The BIM tool salesmen tell us that 3D modelling will solve all of these problems, and they have a piece of technology or software they will sell you to overcome it. So why, when we get a 3D model, do we have the same old problems? And I can tell you, this is part of a model from Terminal 5. Now the stupidity of this is that we trained everybody at Terminal 5 how to do this and how to do this properly. How to use the 3D modelling to produce a clash-free model. The whole process of BS 1192-2007 is about clash avoidance, not about clash detection. And having trained everybody, we still have people going off and doing silly things. So we use clash detection for another purpose. That is, we would check 1 in 10 models, something like that, and we would find out where the clashes were. And because we had control and an audit trail of who produced what, where and when, we knew who had done that. And so we went over and had a friendly chat with them and put them back in the training school until such times as they did this properly. If they didn't change, then somebody else would do the work. This should never happen. We should never have to do clash detection. If we work on a process that the architect produces, and this is just an example, the architect produces a dimensionally stable model, everything in its correct geographical position, and he checks it and signs it off as such. And the structural engineer uses that as a background and builds his model inside or around that architectural fabric. He should, using the technology, know whether it clashes with it. And if it does, he removes it, moves it, whatever. And so in that process, produces a clash-free model, which he then shares with everybody else. And so the MEP comes in, have got 2 clash-free models, one from the architect, one from the structural engineer, do their work, make sure it doesn't touch anything, and therefore they produce, at the end of the day, a 0 defect in terms of spatial coordination and a clash-free set of information. Far better than somebody working over the weekend trying to find out where we've made mistakes, and then somebody trying to manage it on a Monday morning. Who's going to move this first? Should we just get him to move it? I don't know. This is all difficult. If you follow the process, follow the methodology, very simple, think, and collaborate, this does not happen. And it didn't happen, but it took us a little while to make sure it didn't happen. So what is the problem here? We continue to do the same old thing time and time again in the hope that we will get some different results. And we don't. So we have to change what we're doing and the way that we're doing it. One of the problems that we have in proving to people that things do work, processes do work, is that they all stand up and say, what we need to do is another case study. And we have done lots of them. 15 to 20 million pounds worth of case studies over a 20-year period, all paid for by the government between 1990 and 2000. Everybody showed how all these problems could be resolved, published a book, gave it to the industry, who promptly packaged it all up and put it on the bookshelf, never to look at it again. Every time there has been a solution, and it's been demonstrated to make a saving, and it's removed the waste, we have not been able to re-educate, upskill, reskill, whatever the term is you want, to use that knowledge to change our industry. So John Egan, or Sir Michael Latham, started this off with one report produced looking at the problems in our industry, and one of the things he came up with was the client must be central to this change. The intelligent client, you've heard the term, I'm sure, or the knowledgeable client. Next guy that came along was Sir John Egan. Nothing happened after Latham. Has anything changed? No, it hasn't. So we have one book saying there's a problem, and another book saying that nothing's changed. We knew what the problem was, we knew how to solve it, but nothing changed. So John Egan is actually quite central to the change that we have, because he became the CEO of Heathrow Express BAA down at Heathrow Airports when the tunnels collapsed. And he said, I've got this, get this railway running as quickly as I can, not worry about the cost, I need to get the revenue coming in. So look at a different way of working and look at different construction methods, not just as a different way of working, but different construction methods as well, which we did. And that, the results of that was we started using 3D modelling, we started using this idea of clash avoidance in building the models, particularly in the tunnel, because if you don't get it right first time and you bore that hole, you haven't figured out where everything fits, and you certainly are going to go down there and start making it bigger. So you have to plan ahead. 3D modelling helped tremendously in doing that. The success of Heathrow Express has never been understood because the results measured by Anderson Consulting from America for BAA was a private document. What it basically said, half of it was that we have made 20% saving in using these new methods and new construction methods during this project, and had got the delivery back on track. No pun intended. And suggested that as Terminal 5 was coming up, that those same processes and methodologies should go to Terminal 5, which is why the training school was set up, and we had to train everybody to do this. And we looked and measured many, many, many millions of pounds savings. And still nobody believed it. Oh, it's all right on a major project, Crossrail, throw as much money as you like. Terminal 5, the way they wasted money. I bet you can't do it on a small project. This small project happens to be another Egan building. Because this is by a company called BAA Linton, who were the developers for BAA, and they used to develop them around airports. And you can see this building, or this series of buildings. There were 5 or 6 of them built. There are 3 along the Bath Road, just opposite the Ramada Hotel at Heathrow. This one is at Stansted, sits on the approach road on the left-hand side as you go up to the terminal building, and another one was built down the Catwick. Now the thing about this building is that it was going to be built 6 times. What Egan said was, you can reduce the cost of this building and be more efficient, let's say by 10% per year, year upon year, if you keep the same team together. So, the first building went up and it was measured. What happened? What did you do? What were the outcomes? And the outcome was, we knew what the starting price was, but the delivery price was actually 25% up. So the price going in, the price coming out rather, was 25% higher than the price going in. Not a problem, we should learn from this. We put the same team on the second building and we reduced the cost, which they did. The price going in was lower, the price coming out was that lower price plus 20%. So there was something wrong, either in the design, the estimates, whatever. And what it really came down to is starting to look at the construction process and the waste in that process. So on the third building, we put the same processes and methodologies we were using at Chapter 5 into this building, taught the people, showed them how to do it, and then monitored it to see what the outcomes were. And using 3D modelling plus a process, a different way of working, terminal by process, the outcome was a measured saving of 10% of the final project costs in materials only. If you aggregate that up with waste of or reuse of resource, additional resource, etc., it brings you up to about 18–20%. So 3 buildings, great case studies, like-for-like measurements. As it was, some change through learning, even better if you change your process. The interesting thing about this particular thing, when it came to the 4th building, that BAA had decided to sell BAA Limited. And so they rolled the company up, got rid of the directors, whatever, prepared it for sale. Until somebody said, hang on a minute, if we sell this company, do we sell the land on which they've put these buildings? And so, it'll not go there, reinstate the company, put new directors in place, and they awarded the 4th building to a totally different team, who didn't use any of these processes. They went back to the old adversarial way of working, risk, whatever, measured by Turner and Townsend on the 4th building. The price went back up to the cost of the 1st building, and they will give you those measurements. They actually did publish them at the time. So 1st building, 2nd building, 3rd building with process change, 4th building, if you remove the process change and the learning, goes back up again. So this became a very important project in the research and the ability to understand where these problems were. And as I said, in 1994, the Labour report challenged the UK industry to save up to 30% of the cost of building projects year by the use of information technology, per year by the use of it. The government is conservative at the moment in what it's asking for. It's only asking for a 20% change. There are, if you look at the figures on the 2050 group, they will say we want to reduce the cost by 33%. We want to reduce delivery times by 50%. At the moment, the government is being really conservative in asking you, the industry, to try to reduce this by 20% in CapEx. They are also looking for 20% in operation. So CapEx and operation. The government, as client, the message they gave out, is no longer willing to pay for the waste that we generate by producing rubbish information and then having to try to solve it on site. The contractor is a hero because he takes all this information and he still puts the building up, one way or another. It only costs you 25% more to do that. So let's go back to this. What we mean by BIM is the combination of all the discipline-specific models with additional appropriate information produced by the designers, contractors, specialist designers, fabricators, installers, linked to a product model at the end of the day. With it. We now have to exchange design to products. The project information database is transferred over to asset information managers, a new set of data, who will then have to keep that information up to date throughout the life cycle. But it is information plus a model, not just a model on its own. Have a think about this. How much information does the model graphically, geometrically represent of the total data set that is required to put a project on? Anybody want to shout a percentage? You might not. If I said 5%, would you accept that? 95% is all about non-graphical information. No, don't accept 5%, okay? I'd go somewhere between 5 and 10. No more. 90% of the information that we are going to generate and use to produce the building at the end of the day and complete the project is non-graphical information. So we also have to look at the way we manage all of that information, how we share it with one another, how we can mine that data, in a more positive way than we do at the moment. So away from paper into a digital format so that we can actually do that. But the graphical representation which we keep looking at as BIM is only that, in fact, a small proportion of the data that we generate during the project. After all of this shouting and screaming and whatever, when this first started, Paul Morrell first looked at all the work that had been carried out through the Eden programme and quite a lot of other things, building down barriers. I don't know if anybody remembers any of these projects, quite a lot of them, £20 million worth. Said, we are only just beginning to understand the scale of what can be achieved and the amount of waste that can be eliminated from the system. So even he was a little bit taken aback about what the problem was and the fact that we could solve it. I have to keep pointing at the word, because everybody thinks this is about reducing the cost of the building, the footprint cost of the building. And a lot of people saying, I've just reduced this building footprint cost by 20%. I've solved the problem, I've done what the client asked me to do. No, you haven't, because the client expected you to do that anyway. And surely isn't that one of the requirements as you as architects, designers, to make sure that there's value in the end project? So the term he used is waste. There are two things here. One is about getting that cost down, but the other one is about removing the waste in the process of delivering that. So the need to reduce risk and costly error, the need to reduce waste in the design, reduce escalating project costs, deliver tighter deadlines, manage the asset life cycle to reduce cost and carbon. These two words, cost and carbon, we must remember, are also political drivers. The government doesn't have any money, so how do I actually produce more hospitals, more schools, etc., etc. And it is a bog-off, because they've realised that if they can get 5 schools for the cost of building 4, if you can get rid of the waste in the process, this has got to be good business. They've already shown on the NHS projects they've let so far that it is possible that by building 3 hospitals, they can get 5 for the same cost. That is already happening. Tighter deadlines, certainly delivering on time. 50% of all projects in this country, measured last year I think it was, still come in over budget and over time. 50%. It's not all of them, so 50% at least are over cost and over time. We've got a lot of work to do. We want to increase the competition, and mainly what we want to do is get ahead of the game, which we've managed to do in the use of this technology or this methodology, information management, in the global marketplace. There is a document about growth through BIM. I don't know how many have seen that. Okay. There are lots of these documents. They are all free to use. So all you've got to do is look at the BIM Task Group website and you will find them. There is a BIM strategy, there's an industrial strategy, there is a growth strategy, all based around BIM. If we can make our industry 25% more efficient, we can go out, theoretically, with 25% capacity to win more projects, at home and indeed abroad. If you think that seems to be a target too far, or it's never going to happen, what I can tell you is that it's already happening. Out of Malaysia, last year, they wanted to follow the BIM level 2 way of working, but they didn't understand it. And what they did was they put adverts in the paper in the UK asking for UK Revit operators, as if any of them would know what to do. The point is, the message has got over. In Europe, France has already declared that they want BIM level 2, in French form of course, there is a slight modification, by 2017. The Germans have already declared. There are 20 other states in Europe already wanting to adopt the UK method and the UK style mandate. Russia, strangely enough, also declared and they still kept the word BIM in their declaration, which we thought was quite interesting, because usually they try to de-anglicise any comment they make, but they couldn't find anything to replace BIM. Perhaps if we got rid of the acronym for them, it may have helped them a little bit. We also have some Scandinavia, although there are one or two holding out thinking that they've already practiced and they know their way to do it. But they have no measured knowledge that they can put out there and say, we did it this way and we saved money. We have. England is the only place that has this 15, 20 years of research that has proved it. So they are looking towards us to get it going, and Mark Bew, who leads the UK task group, is already setting up the European task group at the moment. So if we don't get ahead and stay ahead, others out there will do it for us. And the two main documents, BS 1192-207 and PAS 1192 Part 2, have already started to be redrafted into an ISO. ISO 19650, 1960, which is unusual in as much as the PAS 1192 Part 2, would normally have to have been produced as a normative document as a British standard code of practice before it was moved to ISO. But in fact, it made the jump very quickly. In 4 meetings already, international meetings, and the document is about 50% through its drafting, and we hope to have it available by the end of the year, or certainly in the first quarter of next year. So we are leading the way, people are following, and people are looking at our standards and methods, and want them as ISO standards. So BIM level 2, this is the key to all of this. This is what government is specifying. What is BIM level 2 and the BIM level 2 package? And most of the industry in this country are also wondering the same thing, because it hasn't as yet been properly articulated. The reason for that is that when we wrote PAS 1192 Part 2, we did say, and we did state all of the documents we needed, and we have been preparing those as quickly as we could. We had to test them along the way. The legal boys in particular had to get there. Others have been added as we've gone along. And the reason why they've been added and why there are a lot of documents is because you, the industry, keep asking too many questions. I don't want to share my information because my IP, my insurer, won't allow me. What do I do? So we went to the insurers and said, what do you think? And they looked at the processes laid out in PAS 1192 and said, hang on a minute, if everybody worked this way, we have a full audit trail of responsibility, who produced what, where and when. If anything goes wrong, we'll be able to place the responsibility in the right place, and we know who is being insured and who isn't being insured. So they loved it. So the excuse of I can't share it disappears. And that's what we've had to do, is to go through and test all of these things. Where we are now, and you would have seen a number of presentations, David Phillips, part of the team, does the 7 pillars of knowledge. You will find on the web there is a thing called BIM for 1 million. Have you all seen that? No? Okay. Go to the website BIM, B1M, BIM for 1 million, and you will find 2 really good presentations. One is about BS 1192-2007, and the other one is about PAS 1192 Part 2. The second one, PAS 1192 Part 2, I think is really good. Because I'm standing here tonight, going to do an hour and a half, whatever. They can do PAS 1192 in 5 minutes. And you can download it, so you can show all your friends as well. Because we really do want to get to 1 million people looking at that particular animation. Hence, BIM for 1 million. And they, BIM for 1 million, actually say there are 8 pillars of knowledge. Well, here I am, just trying to out-pillar everybody. I've got 9. So we have BS 1192-1, 2007. This one is not usually added in to the set because it was produced before we wrote the BIM strategy for the government in 2011. The other reason it's not usually in the pack is because you have to pay for it still. All the other documents are free. And the government said, we want to give you the processes and we will not increase your cost. So the fact you had to pay for that one didn't sit with them right after making that statement, so it tends to be pushed down a bit. It is still at the core and actually has to work with all of these other documents. So BS 1192-2007 is a key document, and it is collaborative production of architectural engineering and construction information. The right word here is collaborative, producing this information together, not adversarially in your own little silos. PAS 1192 Part 2 is the specification for information management for the capital delivery phase of construction projects using building information modelling. The management of the process. Client requirement, how I'm going to do it, how long it's going to take me, mobilisation, I have the right team, I'm going to get on and do it. And Mr. Client, this is how I'm going to do it. PAS 1192 Part 3 is the specification for information management for the operational phase. So we are also doing PIM, but we're also doing AIM. So we're not just looking at the design and construction, but we're looking at the operation of the asset as well, to get to this other 20%, the government wants in office in building use. BS 1192 Part 4, possibly one of the big killer documents, is fulfilling the employer's information exchange requirement using COBE. You all heard of COBE? And I know you haven't, because you had a sharp intake of breath when I mentioned COBE. It's nothing to be frightened of. It's made an impact out there in the world. Everybody talks about it, because people love to talk about things that are poppers. I can't make this work, so I don't have to do it. All it is a simple spreadsheet that says, I want to know this piece of information at this time. Could you please fill it in? The answer is 3. Yep. And there's a whole raft of these cells that you have to fill in. That's all COBE is, forget the word. It is just a spreadsheet of information that the client is asking you to deliver as part of his requirement, and all you have to do is to give that little box an answer. How you do it is maybe a problem. We now have another one that's crept over the hillside recently, or over the palisade, or whatever you like to call it, which is PAS 1192 Part 5, the specification for security-minded building information modelling, digital built environments, and smart asset management. What does that mean? Well, the document's in draft at the moment. I'll show you what it in a moment, and it's right over the top. As soon as you get security guys involved, they just go mad.